In this video I'm going to show you how you can find the integral of x times e to the x, and this is actually very simple to do. So let's look at what we've got here. We've got x times e to the x. Now this is a function, and also e to the x is a function. So we've got two functions multiplied together. So there's a special rule that you use. You do integration by parts. And this will allow you to integrate two functions that are multiplied by each other. And the rule is that you've got u dv equals u times v minus the integral of v du. And u and v are simply just two functions. So this we could call function u, and we could say this is dv, which is the derivative of function v. Now we can decide which of these is u and which of these is going to be dv. So really what we want is we want this v du part, we want this to simply be one function. Otherwise, if this became a function times a function, we'd have the same problem up here. So we'd have to do this all over again or find some clever way to cancel things. So that would be a real nuisance. So let's think about this. Right. If we let u be e to the x and we take the derivative, we're going to get e to the x back again. So that's no use. So let's let u equal x. That would make du equal to 1. The derivative of x is of course 1, and well, that leaves this as dv. You see I already made this selection, which makes sense. And well, what's the integral of this? This is of course just e to the x. So if we substitute these into here, you would get that the integral of x e to the x is equal to x, subbing that in there, v e to the x minus the integral. We've got v is e to the x and du is just 1. And of course we do this integration here. The integral of e to the x is just e to the x. So we get x e to the x minus e to the x. And that is the correct answer. And let's actually explain why this is the case. Well, if you think about it, integration is anti-differentiation. It's integration, it's differentiation backwards. Anti-differentiation. So if you've got x e to the x and you get x e to the x minus e to the x, this is anti-differentiation. So if going the other way would be differentiation. Just write diff for short. So we know that this integrated gives this, the antiderivative of this. So the derivative of this must give us back this. So let's just quickly do that derivative to see that it all checks out. So d by dx of x e to the x minus e to the x. We have a function times a function here, so we're going to have to use the product rule. And you should know what this is. So in this case we would let u equal x, v equal e to the x. So we can simplify this expression here using u dash v plus uv dash. That's the product rule. So d by dx of this x e to the x, just substituting these in, u dash is of course 1, v is e to the x, and then we've got plus, well, v dash is just e to the x and u just stays the same, so x e to the x. And if we substitute this up here, so the result is we've got x e to the substituting this, e to the x plus x e to the x, so this comes down here, and then minus e to the x. So substituted this into here, and this e to the x and this e to the x cancel, which leave us x e to the x. which fulfills exactly what we've got here. So we know because this is the integral, that is obviously going to be the derivative. So that proves that our integration is correct and shows you where that comes from. So hopefully this is helpful to you. You now understand pretty much everything there is to know about doing this integration, and you understand why that is the actual integral. And thank you very much for watching.